Hi everyone, so welcome back to my YouTube channel where I'm going to talk about digital circuits for GATE 2023, and this course is going to be for electronics and communication, for electrical engineering, for instrumentation and computer science. So digital circuits, this subject is quite easy, and you can score maximally from this subject, right? So I hope your preparation might be going well because now application form is also open, right? So you might have filled up GATE application form. So don't delay. Okay, if you want to appear in GATE, okay. So go for computer science, go for electronics and communication, go for electrical engineering, depending upon your key area where you are interested in, right? So let's directly jump into the digital circuits, right? Because I'm going to touch some of the basic concept, okay? And I'm also going to highlight what are the topic which will be asked in GATE 2023, because you always focus on topic like logic gates and Boolean algebra, some simple topics, but there are few topics where you don't focus, and at the end of the day you end up not getting complete marks from this subject, right? So let's directly jump to the whiteboard. That is our favorite board, right? Okay, so let me turn off the video, then we shall straight away discuss, right? So this is going to be our favorite board here, right? So we are going to start digital circuits for gate 023. So here all the branches, I mean, electrical and instrumentation and computer science, these four branches, aspirant can get benefited from this course, right? So this course will be completely according to the GATE syllabus, right? So please make sure that you have to attend every day, okay? Or if you can also watch, once the class is done, or if you have any question you can also ask, right? So I'm going to answer all these things. So sometimes people call it digital electronics, okay, and I like to call digital circuits, right? So where we will discuss many things. So we'll talk about first of all number system, then we'll talk about Boolean algebra and all those things, right? Then we'll talk about variables and literals, minimization techniques, K maps, okay, graphical, and then we will go to talk about combinational circuits, delay in combinational circuits. That is very, very important, right? For ECE, what are the topic you have to focus always? You have to focus on delay in combinational circuits, right? Combinational circuits. Because in digital circuit, you will study two kind of circuits, right? One is combinational, one is sequential, right? And you will also talk about delay in sequential. These are the topic mostly most of the educator skip, right? And you have to realize all the outputs of any kind of circuits using waveforms, right? So waveforms, I mean, you have to draw the waveforms, right? Always. And we have to talk about finite state machine, right? Finite state machine. It is also one important topic which most of the people ignore, right? They always discuss, logic gates and all those things, very basic things. And A to D and way converters, right? This is also one of the very important topic, right? So these are the key topics from where you can expect questions. And combinational circuits, definitely mux and all, right? But we shall start from very basics, right? So you have to discuss about time specification here, timing specification mostly, okay, like timing specification such as setup time, hold time, and setup time, hold time violation, all those things, right? How can you avoid setup and hold time violations? So in ISRO exam also, if in future ISRO will give you the notification, right? So this subject is going to be very, very helpful for you, right? So let's begin directly, with the topics. Okay. So let me check voice and everything is okay. And guys, you can comment. Yeah. So this is going to be for electronics and electrical instrumentation, all these things. If I talk about electronics people, so you might expect around 7 to 8 marks from this, 7 to 8 marks, right? And same, it is applicable to electrical and instrumentation and computer science as well. In computer science, more or less 4 to 6 marks. So electrical systems, or you can say electrical circuits, or classified as, you can say, there are analog systems and there is digital systems, right? So if I talk about electrical systems, right? So electrical system is basically electrical systems, okay, are classified in two category. One is analog, okay, and one is digital. So our discussion will be revolving around digital only. Okay. The nature is analog. Okay, you can't ignore analog systems, right? Because first of all, you will face analog thing around you. Then you will be having some kind of a circuit or kind of a system which will convert analog to digital, right? So in analog systems, in analog circuits, you might have seen amplifiers, you might have seen amplifiers, oscillators, okay, using different kind of circuits like bipolar junction transistor, op amps, MOSFET, all those things, okay, and voltage regulator, music on tape, water on, okay, uh, water on tap, from the tap, right? So these things are what, analog, water, okay, water from tap, okay, you can say. And in case of digital circuits, okay, digital system, you can say, you might have seen your digital computer is one of the best example for digital circuits, right? So digital computer. So we have to study digital circuits, okay, by what we will do here is we will divide all these main topic into subtopic, okay. So we are going to follow some, kind of any problem we will solve, we will go for some divide and conquer rule. We'll divide into sub problems and then we will solve the problems, right? And traffic lights, music on CD, okay, calculators, microprocessor, all those things you have seen in the digital circuits, right? So this is just an introduction I'm telling you, okay. So if I ask you what is analog circuits, okay, or you can say what is analog system, right? So all the physical quantities, or if somebody will ask you what is you can say analog systems, right? Analog systems. So what you will say, all the physical quantities are analog signals, okay. So you can say all physical quantities, right? All physical quantities are, or all physical quantities what you see around you and are analog signals, are analog signals. And you can say continuous time signal, if you see the variation of that quantity with respect to time, okay, so that should be continuous, right? So analog systems are having, basically the continuous time signal, continuous time signals, right? So you can see the example as well, right? Suppose we are in electrical engineering, there are two kind of signals, right? One is voltage signal, one is digital signal, sorry, current signal, right? You can say the variation is like continuous with respect to time, you can say of t. So this is very very important, right? And in case of digital signals, what you will find that the physical quantities are in binary signals, whether you talk about 0 or 1, yes or no, kind of, right? So in case of digital word, okay, digital system, it's just a basics, okay. Any book you can refer where you will find all these things, right? So you will find this kind of waveforms, okay, where 0 and 1, right, all these. there. So you will say this is high, that is plus 5 volt or 0 volt. Okay, so different kind of pulses you will also see in the digital communication if you are from electronics and communications. So a non-return to zero kind of a okay thing. So here we will say one is for plus 5 volt, 0 is for 0 of. In case of digital, we will only talk about 0 and 1s. Okay, and in analog that is continuous. So if any board is having 0 to 7 range, right? Okay. So if somebody will ask you what are the advantage of digital systems, right? What are the advantage of digital circuits? What you will say? What are the advantages of digital circuits, right? So less affected by noise, you have to say. Okay, so advantage of many people ask, right? So advantage of digital systems or circuits, whatever you want to call it, right? So you can say the it is less affected by noise, less affected by noise. And you can see for information storage is easy because nowadays we want to store, we have lot of data around us, right? So after all we have to store, right? So information, whatever information is there, after you have to store, you have to have the memory, right? So information storage is easy and inexpensive. It is versatile because digital systems are programmable, right? So you can also do some programming. Okay, so it is quite versatile. And digital systems are highly accurate, okay, and precise, you can say. And it has high package density. Why it has high package density? You can say it does not use inductor kind of a thing, right? Okay, and it has low power consumption. So these things are very important. Power area is also very important. Low power consumption. So once you will go for GATE, and once you get good rank in GATE examination, so you will go to IIT and ISC. There you will find you have to work on particular area, whether it is you are working in a power, okay, because you have to after all reduce the power consumption, right? And there are various, and you can also go for timing specification side, right? And verification. There are many things, okay, physical verification and all those things. And what are the disadvantage of, if I talk about disadvantage? So I have discussed many advantage, and if I talk about disadvantage, because everybody has some disadvantage. Any system you study should have disadvantage as well. So digital systems are not compatible with real world, okay, and it needs synchronization. So you need to have clock as well all the time, okay. It needs synchronization. It's synchronization. So these are the basic advantages and disadvantages. And so what are the content we are going to study in this complete course, right? So what are the outline, you can say, content which we will be covering? The very first chapter we will be talking about is the number system. Okay, number system. And then we will talk about um, complementary number representation, right? Number representation. Complementary number representation, where many students are facing a lot of problem, like one's complement, representation. So many people face a lot of problem in gate examination, okay, despite they know all these things, okay? They are not able to solve question, they always have kind of confusion and chaos. So we will talk about number system, okay, different kind of number system. So very familiar number system is decimal number system, but basically we will be talking about hexadecimal, octal, and what and binary, okay, binary number system. And we will talk about radix and base concept, all those things. And then we will talk about you can say the binary numbers, because our computer understand only binary things, okay, machine code, okay. And then we'll talk about binary codes. So different kind of codes we will talk here. Okay, gray code. Okay, different kind of codes. And then the fifth is going to be the basics of logic gates, right? So we'll talk about logic gate. It is not a gate what you are going to appear. It will be simple GAT, right? Gates. Okay, so basic gates are like not, and, or. They are the logical operation we will see, and we'll also talk about universal gates, right? So universal gate, we will talk universal gate. So question can be asked from universal gate, right? Then we will talk about Boolean algebra, right? Boolean algebra. Okay. So these topics are very simple and very easy to understand. Okay. You can expect question from universal gate like NAND, NOR, right? And then we'll talk about SOP and POS form representation. Okay, right. This is seventh one, SOP, sum of product, and POS, product of sum, right? And the graphical method we will talk. Okay, that is minimization technique. That is K map. So you will understand K map once I will tell you here. So we will introduce one important concept, that is adjacency rule. Adjacency rule. And if you understand adjacency rule, okay, there we will talk about gray code. We'll use gray code here, fill the K map. So any question you can do, okay, by inspection, right? Okay. And in case of Boolean algebra, while minimizing the Boolean given function, right? So we will use different kind of theorem, right? Consensus theorem and De Morgan's theorem and all, right? And then next will be your ninth one, that is combination circuits, right? So one of the very important yeah, circuits. So I'm not going to write here the subtopics, just I'm highlighting main topic. So combination circuit is again very important, where mostly we will talk about delay, right? We have to introduce delay, okay, all the time delay, like propagation delay in combination circuit. So delay is one of the key topic which will be asked. And then 10th, okay, is going to be sequential circuits. So here we will talk about, you know, latch, then flip flop, then counters, you know, then registers, okay, then finite state machine. And again here also we will talk about delay. So here different kind of delay will be there, right? Here you will see propagation delay, you will see the contamination delays, okay, setup time, hold time, all those things you will find here, right? Here you have to find maximum frequency, okay, all these things, minimum delay and all, right? And then data converters, okay, this is one of the key area where you can also do your masters or PhD, right? Data converters, uh, ADC or D, right? So if you will go for IIT Madras, and if you will pursue your MS in integrated circuit and systems, so you can design various DAC and data converters, okay, under the professor, you know, Shanti Pawan. It's a very important area. And then semiconductor memories. So in fact, I have seen you know, computer science, you know, all the subject in computer science. So if you're yeah, Kratika sir, floating point numbers. Yes, yes, Kratika, yeah. So I will be covering floating point number as well. You know, so in number system, everything will be covered. Don't worry. Okay. So floating point number, till now no question has been asked, but yes, this time one can expect some questions, right? So these are the topic which I will be covering. Okay, in semiconductor memories. Okay, in computer science, everything is all about memories. Okay, storing data, storing all the whatever program you write. Okay, you have to fetch some data from some memory. Again, you store back all those things, right? So I will be conducting all the sessions on computer science as well. Plan is going on. Don't worry. This is what this syllabus is. This is my roadmap. Okay. So guys, let's meet in the fresh session where I will start number system. Okay. Because this was the roadmap. Okay. So I don't want to make this session very long. Okay. So I will start with the number system in the next session, right? This is complete roadmap I have given you. And guys, now you don't have to focus anywhere, right? Because I'm going to give you complete syllabus, okay? And you can see a person is having more than many year of experience, right? Uh, Teaching here and there across the country, everyone knows, right? So I will be able to deliver all the content in very concise and lucid manner, right? So let's meet in the very first session, right? Where I will discuss number system. Okay, so here I'm going to end this session. So I will start with number system, and we will talk about what is number system, how it is related with your high school. Okay, method of representing numbers. Okay, is basically the number system, right? And we will talk about base, radix. Okay, what are the number system you are going to study in this? For gate 2023, right? And what kind of number system is used in computer, right? And we will talk about basic conversions. Okay, we can go from binary to decimal, decimal to binary, hexadecimal versus binary, octal versus binary, all these things. And then we will talk about different kind of base, like base 5, base 16. Okay, base 6, any kind of base, take any kind of base, right? So I will start from the very basic you are familiar with, that is decimal number system, right? And how you perform addition, subtraction, multiplication, division on decimal number system. The same story will go ahead with other number system as well. You have to take, you have to borrow if you are subtracting. You have to also take. I mean, there will be carry producing. Okay, all those things will be there, right? And conversion, decimal to other any number system. Okay, and other number to decimal number system, right? Hexa to octal, all these problems we will discuss, right? And so let's meet in the first session, guys. And please share this session among everyone who are not good at digital circuits and who want to prepare, because we have now 150 days in our hand, right? If you're from electronics, electrical instrumentation, computer science, and you have joined the session institute anywhere, but still you're not satisfied, I know you might not be satisfied from anywhere, because I'm teaching many students personally. So I got to know that they are not satisfied with from anywhere, right? Because they always talk about logic, simple things. They don't focus on these things like delay, okay, and all those things. So most of the people are not able to solve problem, okay, logically. Let's catch up. Thank you.